For our demonstration and practical application of clustering, we are going to do quite a number of clustering algorithms today. And that will help you to fully understand the theory that we did. And sometimes the theory might be too theoretical, and therefore practical work will open the mindset. So we're going to take this study, and this is a data set that we are well aware of. Just to give you a glimpse of the data set, I'm going to open the CSV file for the data set. On the screen here, you will notice that this is a data set for multiple countries. And the country is on the far left. Number of countries are shown there. When you click on this at the bottom, you can see that it keeps going 168 counts, so almost 167. Okay. So as you keep going down, you get all the way, you keep getting all the way. And this will take you to the very last country, which is Zambia. So that means there are 167 countries. Of course, this is not the total number of countries in the world. But because the total number of countries in the world is 195. But at least this gives you some information. Please lower your hands, those of you who answer. Now, this data, the first column is the child mortality rate. So it gives you the mortality rate for children. In other words, the number of times in percentages that children are dying. And you can see, for example, Afghanistan. And we compare Afghanistan with, say, Australia. Okay. You will notice that the percentage of children dying is 90% compared to Australia, which is 4.8. So that shows that a lot of children are dying in Afghanistan. The next column is export. Again, you can see that in percentage, the percentage of exports as a percentage of GDP. Okay, so given the GDP of the country, are these people exporting more? So exports as a percentage of GDP per capita, you can see clearly that Afghanistan is not doing well compared to Australia. Then health. You notice that the health status for Afghanistan and that of Australia, this is the total expenditure on health as a percentage of GDP. How much are they spending on health given their GDP? Then imports. That is the value of the import as a percentage of per capita GDP. Okay. Again, between Afghanistan and Australia, you can see that Afghanistan is importing a lot. Income, that is the net income per person. Okay. What you might call the disposable income. And you will see that, that for Afghanistan is 1,610, and that of Australia is 41,000. So again, you see how poor Afghanistan is looking when it comes to that. Inflation is very high in Afghanistan, 9.44, compared to that of that. This is the inflation rate. And then the average life expectancy in years. How long it takes a person before the person dies on average. In Afghanistan, you have to grow all the way up to 56. That should tell you that people are dying very, very fast. But Australia, you have to grow on average up to 82. So it means that people live longer in these places. Of course, there's a connection in all of this. And then you have total fertility. That is the fertility rate, the average children per woman in the country. How many children per woman? You can see that Afghanistan have 5.82%. There's so many children per woman compared to Australia, which is 1.9. So in most of the developed countries, the rate at which people are giving birth is going down. And then in most of the the less developed countries, people are just giving birth by heart. And then finally, the overall per capita GDP. Okay. That is the income or the average income per person. And you can see that $553 in Afghanistan is average income per year. That is crazily bad. When you look at Australia, for example, it's 51,900, which is quite a number of people on average are doing well. So this is just to give you a feel of the data sets that we are going to be working with. Please, is that clear so far? I need to be sure you are with me. Is that clear so far?
Yes, Doc.
Yes, Doc, it's clear.
Hello, sir. Sir, please, good morning. Sorry to take us back, but some of us just joined.
Okay.
Really sorry. If you can please go over just one short time. Thank you.
Oh, this was nothing basically. This if you can just go over. This was nothing. I was just opening the document that you already have, and I've sent you this document. It's called country data, and I just opened that country data in Excel. I mean in CSV, and I was just walking your colleagues through one by one what each variable means. That's all. It's nothing big deal. I wanted them to have a feel of it. So we will be talking about them again as we go through the Jupyter Notebook anyway. So just ensure that you've opened your Jupyter Notebook, which is what is on the screen now, because that's the most important. So everything I said is also in your Jupyter Notebook. Every interpretation of the information is here on the Jupyter Notebook. So I'm not showing you something that you don't already, unless you don't have this document. Then in that case, you can ask. All right. So this data set, we are not doing clustering on the GDP. Okay. We want to rather understand the variability of the other factors. Apart from GDP, you have income, you have inflation, life expectancy. We want to understand these factors with GDP across the groups that we have. We want to understand. And this can be your complete thesis, honestly. For example, your thesis can be that you want to look at the impact of maybe, you want to look at the impact of life expectancy on the GDP of these countries. Or you want to look at the effect of exports and imports on the GDP. But you want to also cluster these across the groups so that you'll be able to see how these variables differ or vary across the groups. Remember, the purpose of this study basically is, as you can see here, foundational to understanding and shaping the future of societies. The things that shape the future of society, they are the things we've gone through. And the extreme interest to various governments and non-governmental institutions. We know that GDP is one of the most popular measures used in the popular vernacular. Everything, if you want to know how well a country is doing, we say GDP. But then, as you can see down here, there are other factors. It's not the only measure of the economic growth of a country. So we are going to deep dive into such factors, such socio-economic factors for countries, and then identify if there exist various groups of countries, clusters of countries that are more similar to each other in terms of some particular socioeconomic factors. So maybe there are some, what eventually led to some countries being called less developed countries? What led to some countries being called developing countries? That was a cluster name. What led to some countries to be called developed countries? What factors define them as developed? Okay, and that's what we want to look at here. Okay, so the first thing to do is to import the various libraries. Okay, now I would encourage you to be running them as we do to ensure that we are on the same page. Now, if you look at your data, we are going to import quite a number of libraries, such as Pandas, NumPy, Matplotlib, Seaborn, all of these things, you know them already. But one particular one I wanted to take note is the standard scaler. Has any of you ever heard about a standard scaler? Any of you heard about a standard scaler? All right. You need a standard scaler. You talk a lot about it also when it comes to principal component analysis. The standard scaler, and guys, like I told you before, it's a communication. So whether or not you've heard something, it's important you let me know, if I ask you, because that will make me know that you are listening. The moment I keep talking by myself, by the time I realize I was sunk into a speedometer and I don't know where I am. So I will implore you to be responding.
Yes, sir. All right.
So the standard scaler is like a Z. I mean, you've been doing statistics for business analytics. It's like that Z, standardized Z formula, which you can use to standardize any number. Okay. And sometimes certain things have got bigger values, others have got smaller values. So you want to bring all of them together to a scale of, say, between 0 and 1. So the standard scaler is usually there, used a lot in data preprocessing to help you. And you will need this in your dissertation, most of you. Then you will import the clustering algorithms. See here we have k-means we are importing, and then we have the Gaussian mixture as well. It's one of the clustering algorithms. In fact, there is also the k-medoids that we spoke about. Okay. Who can remind us quickly what is the difference between the k-means and the k-medoids? Anybody? Anybody? I mean, from last time. What is the difference between the k-means and the k-medoids? Pascal.
Doc, so basically the K means uses the average means of the various data points, whilst the K methods uses the median.
So what is good about one of them than the other? What is good about one of them? This
K methods is good for data points which have outliers, as outliers will not have much impact on it compared to the K means.
Yes, but even though you spoke about the median, it's not really exactly the median. But what is the main difference between the k-means and the k-methods? You spoke about it the last time. The main difference, Esther.
So with the methods, it uses the actual data points.
Exactly.
Yeah.
That's a key point. And the actual data point is what we call the method. Take note. See, this is where you got to be writing notes if you've forgotten from last time. So the actual data point, the most centrally located actual data point, that is the method. Okay. And then the goal, when you look at the way the two of them behave, the k-means will minimize the sum of square distance. We know this in last years. The sum of square distance between data points and then the cluster mean. That's what the k-mean is doing. Whereas the method is minimizing the sum of pairwise dissimilarities, between the data point and then their method. So those are some of the main differences between the two. And now today we are going to be looking at both of them at the same time. We are not importing the methods here, and you will understand later why we are not importing it here. We will import it later because it's quite complex to add it to this importation, because the more you are importing so many things at the same time, sometimes your computer, the system the kernel can even crash. So it's important to import the easy ones. And finally, we will import the silhouette score. The silhouette score is used to measure cohesion and separation. We've said this thing before. The silhouette score is also used to determine how many clusters, how many groups you want to have. So we are importing that. So all of these are being imported. So guys, now I want you to run your command. If you have a problem after running your command, you will know how to handle it. You told how to handle it. So run your command for this. Computer is a bit slow. Let me read. I don't know why this thing is not running. Let me see by hands if you have been able to run that command. I mean the first command. If you have been able to run yours, okay, Grace has done that. Very good, very good. So let me do the mine too. Ensure that you are going along. Okay. So it's done perfectly. The next thing is to load your data set. So let's move. Your data set, this command has your data set, and the data set is actually called country data, country dash data. This is a CSV file. So it's important that you add .csv to it. Remember, it's not an Excel file. It's not an Excel file. Okay. So note the difference between a CSV file and an Excel file. If it was an Excel file, then you would have added what? .xlsx. But then it's not an Excel file. It's rather a CSV file. So we'll take it as a CSV file. Now, this second part here will show the head of the data. The head of the data is just the first 5 rows of the data, which is 0 to 4. So we run this command and then show the head of the data. And you can see that it just gives us the head of the data. Now, if you don't want the head of the data, but you want the tail of the data, so you just run this and change this one to tail. And watch what happens. It will also give you the tail of the data. So you see, it has given us the bottom half of the data, which is 166. Well, it's actually 167 because it starts from 0. And that is Zambia. So Zambia is the last row of the data set. Okay, I mean, I just added that. That wasn't given to you, but you can add that so that you know. And sometimes this information we are giving you, you can be writing them on the side. Guys, let me ask you, have you been using Python and Jupyter Notebook apart from this course? Have you been using it anywhere else? Programming for analytics, are you using it?
Yes, sir.
Also,
So you know all of these, don't you?
Yes, sir.
Oh, good. Then I'm talking too much. Taking it to the beginning. All right, so now you have this data set. There are some few things you got to check on the data. And you will need these things also in your dissertation. So it's important that you are enjoying this or you are understanding this, basically. If you want some information about your data, you can use this command to find information about your data. Once you run this command, which I just did, it's going to give you information. So it tells you the number of countries is 167. And it starts all the way from 0 to 166. Okay. And then it gives you for each column, what is the name of the column? The first column is country name. The second column is child mortality rate. And then the rest will continue. It also gives you at the end which variables are float, which are integers, which are objects. And based on this, you know that 7 of them are float, 4 of them are integers, and then 1 is unknown. Who can tell me which is the object? Who can tell me which one is the object? Oh, it's even on the right side here, so you can easily see them. Get to me. So This information is something you should be able to get a feel of. So what is the first thing you can get? One, similar things I've already mentioned. There are 167 observations, 10 columns. All the columns have got 167 non-null value. In other words, they are not missing values. Now, if there were missing values, you would have been informed. And how do you know that? By looking at this column here, you see 167 non-null. So that tells you that there is no missing value there. If there are missing values, you may drop them or you may interpolate. Okay? You may use some means to be able to fill in the gap, a backward or forward filling to fill in the gap so that let's say the life expectancy values is not 167, but then it's rather 164. So the other three, you can use some interpolation method to fill in the gap. But here, there's no missing value. Also, you can see that all the columns except country column are numerical. So that's why country is object. So now that you see that everything is good, you can now move ahead and check whether they are duplicates. For example, is there a particular duplicate in some of the rows or columns? You will run this command to indicate whether they are duplicates. So please, I want you to run that. We're trying to run everything so that you're on the same page. And this means that, remember, we have documented this. This wasn't written by the architect. This is what Python is giving you. Okay. And these are my notes, which should be your notes when you are running a similar one. And this shows that there are no duplicates on the rows. So we are good. You can now do your exploratory data analysis. And what is that? It is trying to do some basic, analysis to have a feel and making sure that the data is well described. So the first thing to do is you can run this command to describe the data set. The T indicates that the thing should be transposed. Transpose here means that it should be made vertical if it is horizontal. So let's run this and you get this. Okay. But if you had removed the transpose, the thing will turn horizontal. Let's try that. So you can see that here the child is rather, and then the descriptive statistics are on the vertical section here. But we don't want that. We want the descriptive statistics to rather be at the top. So that is why we do the transpose. Then they come at the top, as you can see here. And now the variables in question will be on the left. Remember that Python is also sensible. You will notice that it did not bring that of country, because country includes Afghanistan, Australia, and several countries. So it did not include these countries in the data set. It's not part of the data. You can't take a descriptive statistic of a string variable and categorical variable. And that is why it's ignored it. R also does the same thing. So what are your observations? Anybody, what do you observe from here? What are the things you observe from the results? One, in fact, you have them in the note, but ideally I would have asked you, what do you observe? Quick thing, and I want to put this across so that you know it for next time. Do you realize that for some of the variables, like child mortality, the standard deviation is more than the mean? It's not the same for export. No, for export, the standard deviation is less than the mean. But for some of the variables, the standard deviation is more than the mean. In fact, for inflation like this, the standard deviation is more than the mean. What does that mean? What is the implication of that? Who can tell us? What is the implication of the standard deviation being more than? And I guarantee you guys, please take note of this, because you will meet this next semester when I'm teaching you research methods, and you will also meet this in your dissertation itself. Anybody? Okay. First, look at the minimum value for child mortality and then the maximum value for child mortality. What does that tell you? the minimum value for child mortality and the maximum value for child mortality that you are seeing here. What does that tell you? Yes, Pascal.
Dog, it means it's widely dispersed.
What is widely dispersed?
The mortality rate.
What does that mean?
So we have a lot from different countries. We have there's a gap between the number of children who die, basically.
To a 7-year-old child, how do you say it?
Sorry?
When you are talking to a 7-year-old child, how will you simply explain it? In simple terms.
It means a gap between the mortality rates of the countries is wide apart.
Yeah, but what does that mean? What does that mean? What does that mean in simple language?
Doc, it means for some countries they have very low mortality rate, whilst others have very high mortality rate.
That is what a 7-year-old child will understand. That's it. Okay. So maybe when you use the word a gap between the 7-year-old child, you break it down. The ability to break things down, that is a real measure of understanding. Okay. So it means that some countries, people are dying very much. In other countries, people are not dying at all, relatively speaking. Now, that is what is reflected in the standard deviation being bigger than the mean. So for your information, and you should always talk about this in any descriptive statistic, that anytime there is a standard deviation which is more than the mean, it means there's a lot of variability between the values. It means that size matters. It means that do not ignore size. That's what it means. Do not ignore size in any way. And that is important. Okay, let's move on. So some of the things that I said, they are here. And you can pick on each one of them. So as an example, it says that overall percentage of health, average life expectancy seems to have lesser standard deviation, which reflects less variability. All the other variables have high spread across countries. And these are the variables that might help us identify clusters if they exist. So you need to be able to find out some information about this. And when you have an exam, some of these descriptive statistics are given you. And when they are given to you, they require you to write information about them, like you can see right here. There are several things you can say. For example, the total spend on health is very less as compared to the export and import for majority of the countries. Okay. You can see that here. And you can see that the average spend on health is approximately 6.8% of GDP. And that is here. Okay. When you come to the results here, you see it's 6.8% of GDP. Okay. So you should be able to have a feel of the data and speak to your result. The next thing is to check the distribution of each variable to see whether they are outliers. You see, distribution is how the data is spread. And to do that, you will use this command. Remember, the name of the data is data. So we are taking each column in the data, and then we will indicate the distribution. You will print the skewness. You will indicate the size of the figure. Okay. You would even want it to give you subplots. And then you can negotiate your result. Now, the PLT at the bottom will give you the result that you want. Now, this is a Seaborn, and we are using box plot to represent. We are using box plots. We are using histogram. So you can see that we are using histogram to show the result, and we are also using box plot to show the result. It's not only box plot, but we are using two figures because these two are very good in detecting centrality as well as distribution. In fact, if it was possible, we could even use kernel density plot, okay, the bell-shaped curve. That can also reveal whether it is normally distributed or whether there are outliers. But the box plot is very good in detecting outliers. Volume plot is also very good in detecting outliers. Straight plot is also good in detecting outliers. All of these are possible. Yes, Jenny.
Debbie, good morning. And please, I want to find out, with what we are doing, does it mean that if we are given any data sets, this is the methodology to go about it? Like how to start trying to analyze it and find the clusters and all that?
No. It depends on your research question. It depends on what you are looking for. Here, we are going to undertake clustering. Okay, so that's why we are doing this. But there are some people, they will not do this. For example, this very one that we are doing for each variable, we will not do that for other algorithms, other methods. Okay. Every data that you have, the kind of question you have will define what you are supposed to do. So there is no, robotic, automatic way of doing the thing. But they are standard. For example, they are standard. For example, the descriptive statistics I showed, okay, is going to happen to most of the analysis you do. I mean, most of the algorithms, especially when you come and learn supervised machine learning, you see that you have to do that all the time. So I will not say that every time you are doing any work in Python or in business analytics, you got to go through it.
Yes, please. Thank you.
All right. But it's a standard, and the standard, in fact, these things are not, how do I put it? They are not crime. It's good. It's good to do all this. But I'm saying that there are even more things to do. There's no crime in doing it because doing it will make you feel the data. And we're going to feel the data right now, you see. So, for example, let's take the child mortality. You see that the skewness is 1.5. And then look on the far right. What are those dots you see there? Come tell us. What are those dots? Samuel.
So those are outliers.
And what is this? What is this figure? Pascal, what is this figure?
That's the interquartile range.
No. What the whole of this figure? The whole of this. What is
Well,
that?
that's the box plot of the child mortality.
Okay. So this box plot is revealing outliers. And the outliers are, when you look at these outliers, okay, and compare it with some of these other ones, look at the outliers very carefully. By the way, the histogram will give you a feel as to whether, if you look at the histogram for each variable on the left, it will give you a feel of whether the data is normal or is not normal. But look at the outliers carefully. Look at the outliers carefully. Look at the outliers carefully. Compare those outliers with this one, life expectancy. What do you see about the life expectancy outliers, okay, and the rest of the other outliers? What do you see? Who can spot something? Can spot something. What do you notice? Pascal.
Doc, for most of the outliers for most of the other variables, they are at the upper quartile, whilst the life expectancy is at the lower quartile.
Okay. And these are some of the observations you have spotted. Okay. So this point has been indicated here. That first of all, most of the variables have got skewed distributions, and you can see it on the normal distribution. Most of them, the distribution is very skewed. But the life expectancy, okay, that is the only variable which is skewed to the left. And what that means is that most of the countries have been successful in achieving high life expectancy. Okay. In other words, majority of them, people are not dying too much. That is why you can see that life expectancy, is on the skew to the left. Only few of them have more people die. The majority of them have less people die. Okay. So those are some of the observations you can see. But the key point is that they are outliers and they are not normally distributed. Okay. This write-up I've just put here, because you have it, that's why I'm reading to you. But normally, you would have to comment on all of this. You will have to document this. You will see that a lot, in exams and you should be able to look at the figure and speak to the figure and indicate what the figure is telling you. All right, let's move on. Next, we would look at correlations. Has any of you been taught correlation in this course? Has it come up anywhere? Has it come up anywhere? What is correlation? What is correlation? Do you guys hear some noise from computer? Yeah, Kabiru.
Yes, sir. Correlation is the relationship between two data points.
Between?
Two data points.
Between two data. All right, so the correlation can be positive or negative or zero. And so what we are going to do right now is to use the sieve on the heat map to generate correlation. Okay. And apart from this picture, by the way, take note that this picture will give you several other different things. You can have the correlation in different ways. Okay. Using the heat map, see this command here, you can generate that with a different color, with a different look of the correlation. You can, have a different example of that. So you can just run this one and then use a different one. But this will plot the correlation matrix for you. And in all correlation matrices, I'm going to run that, you should run that. In all correlation matrices, you will notice. Okay, so there's a problem there. And sometimes you will have some of these things, and when you do, you don't have to worry much, because it simply means that sometimes you can just indicate how the figure should look like. So I'm just going to rerun this. Okay. When you encounter situations like this, there's an easy way to solve some of these things. You need to drop the string variables so that you can correct that anomaly. But for you and at your level, one of the easy things you can do is you can just take it to the chart, and then it will easily correct the situation for you. So the key point is that you have numeric columns, and this thing requires numeric columns. Okay, so you can force it and let it know that this is numeric. You can tell R that you can tell Python that this is numeric. Okay, so I'm just going to put that here. I'm just going to copy this and put that here for this command. And then let's run that and see. So you see, it gives you information. Now, it's a slightly different thing from the one you already have, but it's the same value you are getting here. So if you got that, what you would do is retype this command. In fact, you have some of them already. Okay, for example, let me just undo this, and then you see. Okay, this is it. This is what you had before. Okay, and then I've replaced it with that. So obviously, you have some of them already shown. So you are using the heat map And then you are indicating that I want you to just select only those that are numbers. That's it. Okay. So in the data, I want you to just include only those that are numbers. And in the first column, which is country name, which is not numbers, that one will be removed. And then everything else will remain as it is. Please run this and let me know. And if you're able to get that done, raise your hand and let me see. Yes, upon.
So I did that, but I think I used, when I got an error, I copied it to Gemini to correct it for me. And he also gave me a similar thing, but let me drop the code I used in the chat so you can see. I think if you run that one, you get a similar thing.
Yeah, once you get a similar thing, that's okay.
Okay, sure.
There are several codes that will, as long as it's giving you the key point.
Thank you.
Who else has done that? Who else has been able to run this? I'll need most of you to be able to run it. So show your hands when you've been able to run. I need most of you to be able to do this. So if you've been able to do it, let me know. Now remember that CMAP, you can change it. You can change and use something like blues. Blues will give you something like what I'm showing you here. So you can use different kind of character for it. You can even use greens. You can use you can use greens. You can use oranges like this. So you can use different colors but you consider the diagonal is indicating 1, 1, 1, indicating perfect correlation. And then some of the correlations are negative, some of them are positive. I'm sure you guys know how to read correlations. Read it the way you want it. But I consider most of you have been able to do it, so you can proceed. You can lower your hands now. How do you interpret this correlation? It's simple. You pick a value from the x-axis, say export, and you want to match export with another value, say import. So look here, okay, export and import, the correlation is what, 0.74, positive, which means there's a positive correlation between export and import in this data. There's a positive correlation. But the key point is that now we need to find which variables are highly correlated with GDP per capita, because GDP is the key measure of economic growth. And so GDP is the last column here, the last column, GDP per capita. So I'll look vertically straight and I'll look for the biggest value, okay? And the biggest value in positive terms is export. You can see that, okay? It's 42%, which means that there's a positive association, 42% positive association between export and GDP, which means that as GDP is going up, export is going up as it, export is going up. Yes, somewhat.
So please, I was thinking the GDP is more, the highest value there is 0.9 rather. I don't know if I'm wrong. And that maps to income.
Oh, yeah. It's true. Sorry. So true. Thank you. I didn't even spot that. And that is another interesting thing you will know. Sometimes you become, especially in an exam, you will not even be able to spot that because sometimes it's so large and so many, 24 against 24. So you have to comb through to be able to dictate. In fact, there's even 0.6. I can't believe I went to 42%. Okay? I didn't even see 0.6. So yes, it's 90%. There's a 90% correlation between income and GDP. As your GDP is going up, disposable income is going up for everyone. So you're able to get the positivity between GDP and several other countries. There's a strong positive correlation there. Okay, and this makes sense. Now look at life expectancy. Countries with high GDP, many people have got high life expectancy. So when you look at life expectancy, it's 60%, which shows that people live longer in richer countries. Richer here being defined by the high per capita GDP. And then there's a negative correlation between life expectancy and child mortality. Who can tell me why? This is child mortality here, okay, and life expectancy is negative 89%. Who can tell what is the reasoning behind that? Negative correlation between life expectancy and child mortality. What is the practical reasoning behind that? Who can tell us? People where, they are living longer. Places where people, yes, Annette.
All right, sir. So when there's high child mortality rate, that means that when they're finding the average age of death, the outlier on the lower side would be so high that when they find the mean or the average age, it would be a very lower age. So then the life expectancy.
Without mentioning outliers and all of those.
Sorry?
Speak to a 7-year-old child in your answer than speaking to a lecturer.
All right. So that means that when you are in a country with high child mortality rate, that means that the average age they are expecting someone to die would be very low as compared to other countries where there's low child mortality rate.
Why? Why? What is a potential reason why? So one thing about statistics is that one thing about machine learning, statistics, all of that is that you speak more practical to the numbers.
Okay, so the why is because the people die at a low age. That's the why.
People die at
a low age, a lower age.
I don't understand.
So child mortality means that the number of people who die when either they give birth to them or in their first few months or years on earth is high. So in the grand scheme of things, for a particular country, so long as your child mortality rate is high, that will mean that there are lots of people dying at a very low age.
Yes, so
the life expectancy for an average person in that country would be at a low age.
Okay. Good. Richard.
Yes, Jeff, so please, what I also understand is that the fewer deaths among children, the more individuals who survive, i.e., when they grow or beyond.
Why? Why, Richard? Anyway, we are not going to do social population census or course here, but I just want you to be able to always understand what you are seeing, the numbers you are seeing. Okay? You should always try to understand. Now, the child mortality has a very strong positive correlation with fertility, which again shows that if people are giving birth a lot and the population is going higher, okay, there's a high likelihood because resources are stretched. The resources are limited, and now you're giving birth too much, high population, Manzurian theory will come in, and so some way, somehow, it will lead to death rates, because you can't get the resources to be able to take care of most of them. So you should be able to make some sense of some of these things. Let's move on to the substantive matters. The next thing is to scale the data, because you're going to do clustering. Okay, clustering has to do with distance-based algorithm. You're dealing with distances, and all distance-based algorithms are affected by the scale of measurement. So it is very important to standardize the scale before you apply clustering. Now, before you standardize the scale, you need to drop some variables. And the reason why we are dropping country is because, first of all, country is a string variable. So that's one. But why do you think we are dropping GDP per capita? I mean, I'm speaking from here. We are dropping country, all right. But why do you think we are dropping GDP per capita? Who can tell us? Esther.
So before we started, you said you wanted to, the objective of this was to look at the other things that affect the socioeconomic factors in the country. That's why we don't need the GDP for the clustering.
Okay. Yes, Samuel. Why are we dropping the GDP per capita from the data before we do the scaling?
So when we go back a bit to see the box diagram, we see that GDP per capita has the highest, most of the outliers, a lot of outliers in the box diagram. That's what I think.
Okay. Yeah, some more. What is the purpose of scaling? Scaling. Scaling has to do with standardization or normalization. We use scaling to make all the features comparable in magnitude. That's what we use scaling for. When I say features, do you all understand features? The features here represent, if you were doing a regression or a classification, the features here are what you might call the independent variable. Okay. For example, one particular variable can be measured in dollars. Another variable can be measured in percentage. Another variable can be measured in tons or kilograms, different scales. So we are going to use a scale, but the scaling is not for the target variable, which in this case is GDP, because that one is what you are going to predict. But the scaling is for the features. And the features are all other variables except the target variable. And they are the ones you are going to train as well. The features. They are the ones you are going to be training. And therefore, that is the one you scale. So by scaling, you are bringing all the features to a common scale. If you are using the standard scaler, it's going to deal with the mean. The mean is going to be 0, the standard deviation is going to be 1. But if you are dealing with what you call the min-max scalar, min-max, the minimum maximum scalar, okay, that one will give you a range of between 0 and 1. But the key point I asked you is why you drop GDP, because it is the target variable. It is not an input feature. And because it's a target or is a dependent variable, that you don't apply scaling to. So keep note of that. I know this work is not really indicated that if we are doing clustering, but clustering is a method that will usually precede regression anyway. So that is why you can see that we are dropping this particular independent factor. Okay, so how do you do the scaling? So this command will do the dropping. Okay, run that. So we now create a new data set. We call it data new. We use a standard scaler because we've imported it already. Remember, we are having data scale. We give a name to this word, data scale. This data scale is actually a new data frame which is going to be created after fitting a transformation on the new data. Okay. Remember, we created a new data here at the top. And now we scale that new data, because what made it new is that we drop country and GDP data. Now we are scaling it. So we are going to have a new data set called what? Data scaled. And the top part of that data scaled is these values. Check the values carefully and you see that they are all within the same numbering. They are all between 0 and, they are all around the same figure. Check it. Go to the top of the data set, the original one. And in this original data, look at some of them. Some of them are 46, some of them are 72, some of them are even 4,480, some of them are 60,000. So some are too big, some are too small. But now, look at it. I'm going to show the top part of this data set. Let me show you something. Let me show you something. Because I want you to compare that. So this is for Afghanistan. And look at for Afghanistan, for child mortality is 90, and then for income is 1,006. Let's come now to Afghanistan in the scale data set. In the scale data set. Look at Afghanistan. Okay. Child mortality is 1.29, income is 9. So you can see that they are all within a similar number. We have scaled the data now. The good thing about this scaling is that it makes clustering work perfectly. Any question? So now we can create a copy of the data set to store labels from each algorithm. So normally you can create this copy and then store. It will be needed. Okay. Oh, it looks like I've not run this. Have I run this? No, I haven't. So let me run the standard scalar one. Okay. So now this is it. We got the same values now. Okay. And then we can store the data. So now we can keep a copy of the data. We've kept a copy of the data. Okay. Yes, Jenny.
Please, I want to find out the standard scalar. What value does it use in computing the?
You remember this one? Okay, x minus mu over sigma. Remember this one you did in statistics?
Yes.
This is what it's calculating for each value.
Okay.
So we bring all of them to the z value. Okay, you remember the z value?
Yes.
Remember that z value, when you draw a normal distribution curve like this, the z value, the middle here is 0, and anything to the left is negative. Anything to the right is positive. But then the key point is that they are all around the 0. That's the key point. They are not too far away from the 0. And as you can see, the values here, they are all like that. So you bring all of them into the bell-shaped curve. So the key point is that we are converting all the numbers into that z value. Of course, you would have to, behind the scene, what it has done is that it's calculated the mean of the entire column, and it has calculated the standard deviation of the entire column, and it is used that, and the x is the original variable. So the x is maybe the 16,000. And then it will take the 16,000 minus the mean divided by the standard deviation, and it will use that to calculate for each column. Please do follow. Yeah.
Thank you.
All right. So once you've done this, you are ready to now apply your k-means clustering. How do you do that? Well, as you know, the first thing is we need to find the SSE for each value of k. Okay. The sum of squared error. And then, as we know, we need to iterate for a range of the k's and fit the scale data we have to the algorithm. We use inertia attribute for the clustering, store the inertia, use it to calculate. Remember here, you can see that I've got the n clusters to be k. Okay. Just as we did with the first time, we calculate, because right now, before you do your k-means, you need to identify the number of k's you're going to use. How many groups are we going to have? And the last time we indicated that you have to use the SSE, the sum of squared error, to find that by plotting your curve. And in the process of plotting your curve, you will look for the elbow effect. Okay. So this whole command just creates the curve and plot the elbow. Now, this is a plot of the elbow. And the essence of this is just to know how many Ks you're going to use. That's all. How many Ks you're going to use. Remember, this data is quite big. And we have 167 countries. And we have a number of observations as well in it. And we are going to group these countries according to something. The question is 167. How many groups are we going to have? 2 groups, 4 groups, 6 groups, 7 groups? That's what this one is doing. So when you run this, let's run it. There you go. So you can see that Based on this, just looking at it, where is the elbow effect? Where does it appear like there is an elbow effect? Perfect. Yes. But then why can we say that that is not really the elbow? Why can we say?
After that once.
Sorry?
It still keeps dropping after the after point two.
You say after point two has done what?
The graph still keeps dropping like after the point two.
Exactly. Okay. It's supposed to kind of bend properly, but now it's not really bending. So we can now say that the elbow effect is actually from 2. Okay, and that is the point that we've indicated, that the dip starts from 2 all the way to 8. It's going to be in between there. There's not a clear elbow here. It can be 2, it can be 3, it can be 4. So any of them is fine. You can choose between 2 and 8 as your number of clusters. And so that means that you're going to do a lot of, clustering for 2, for 3, for 4, and things like that. So this probably didn't help us much. So we need to look for another opinion. Okay? You need to get a second opinion from mathematics. And instead of using the SSE, let's go and use the silhouette score. The silhouette score is also used to check the number of clusters to use. How do you do that? Well, this is a command for the silhouette score. Again, you go through the same process, but when it comes to the SSE, instead of the SSE here on the scale data, you rather use the silhouette score. And then we run this command, it will plot the silhouette score. And let's see the elbow for that. So again, look at that. Now, one thing about the silhouette score, unlike that of the SSE, is that the silhouette score, it is the higher one you are looking for. When I say the higher one, I mean from the higher, the first elbow, not the higher one, the first elbow you're looking for. And even though you see that if you take it from 2 to 3, after 3, there is a clear elbow. Of course, it goes up and comes, but there's a first one that you're looking for. So you can see from the score that the highest cluster should be at cluster 3. Even though the thing rises, that is the first one. So that tells, it makes it slightly easy now for us that we can use cluster 3, to be able to do the work, and therefore there are 3 clusters. Now, it doesn't make it permanent, because remember, we said originally the SSE with its elbow told us that we are going to sink between 2 and 8. Okay, but this one has given us at least a number to dance with. So we're going to take the number of clusters as 3. If you don't do it like that, you will be running a lot, but you have to start from somewhere. Yes, I will.
So, please, I wanted to find out if the elbow you choose, must it always point downwards, or there can be cases where it will point upwards?
Okay. When you say point upward, I want to understand. I want to understand what you mean by point upward.
So, I mean, so the elbow we choose for the image you are showing right now is the first bend is actually pointing towards 3.
Yeah.
And you see the others are actually pointing upwards.
When you say upwards, I want you to give me.
As in, the peak of the bend is upwards.
Yeah. Give me one example so that I'll know.
So 4.
So,
for example, if let's say the first point started at 3, started going up, then the bend started around 4.
going up, the up one is not even part at all. So the next possible one would have been 6.
6.
Yeah, that's
So
a,
that's why I'm asking if like the elbow you choose, it must always point downwards,
yeah,
as in the peak
it's the one that is down, not the ones that are up.
that
So
are up. Okay.
in this case, all these ones at the top here, they are not going to be part of the elbows.
Okay.
But these
Okay.
ones are going to be. But
Okay.
then we will take the first one.
All right. Thank you.
And when we come to principal component analysis, again, these things will come up. Okay. So now we are ready to run our k-means. This time you can see that in this command here, we are running our k-means with 3 clusters now. So the number of clusters is now 3. We will fit everything on the scale data, not on our original data, but on the scale data. And here we will add predicted labels to the original data and the scale data because we want to see the labels. And then we will run. Remember that we created what do you call it? We created a copy of the data scale. So we use that for the labels. And then we'll run the k-means on the predicted scales. And when you do that, and then you can now go and show your results, you get something like this. Oh, this thing has changed. It's still good. So on the 3, you can see that, oh, this one has actually, that's interesting. But you can see that which group 0, has got more elements. Remember, we are talking about 167. And when you add 67 to 59 to 41, that is 167. So you can see that the first group has got 67 elements. Then the second group has got 41 elements. And then the third cluster, this one is right. And the third cluster, let me just clean what Swansea has written. The third cluster has got the other information. So the data originally would have been very skewed, but from what I'm seeing, it doesn't seem to be that much skewed. Unlike before, I personally don't know what the results have even changed now. But originally, if you check the original value, the data were skewed because there were more people inside group 0 than there were more people inside group 2 or group 1. But now, what I'm seeing, okay, is that they appear to be balanced in, not in one cluster and more in another. So this that we just ran looks good. Looks good. Damn, this one. So we can just go and show this. But I just wanted to know something here. We are going to calculate the mean and the median of the original data. The mean and the median of the original data is this for each group. This command will do for each group. But with what we have just done now, and watch this. That's how behind is that.
Yes, Doc. When I run mine, I'm getting different values. I don't know what could be the cause. I didn't alter anything. And even the silhouette score, the chart above, mine is looking different from yours. So I don't know.
Angela, you have the same thing.
Yeah, but mine is an error. It says data scale copy not defined. But I also haven't touched anything.
Oh, don't worry if you haven't touched it. Sometimes your computer can bring errors. Sometimes some slight typos can bring errors. Sometimes it's the speed of your computer can even bring errors. So what I would normally say is that take that error and post it where I told you to post it and see what it will say to you. But let me go to your point of Shaibu. What did you get? Okay, we've finished silhouette, but now you are talking about silhouette score. So
Yes. So after I ran the silhouette, I don't know if the curve, I would have loved for you to see how the curve looks like. before the values itself, the k-mean, the values. For the 0, I had like 107. The second one I had 51, and the one I had 9. So I don't know.
Yeah, no problem. No problem. I mean, you can see that even my own, I got a difference because there's a lot of iterations that are happening. Okay?
Okay.
So it could be that, and there's randomizations as well. So it could be that, so sometimes you have to run it again and again. And once you get the same value, once you get a repeated value, then you know that what you did is what you did. It won't change significantly. It will lead to the same conclusion, even though the numbers may change. So the question I want you to find out is looking at yours, did you get 3 clusters or not?
Yes, 3.
Yeah. So that is the key thing.
So that's why I asked the question that must the elbow always point downwards, because mine is pointing upwards, but then it chose the cluster as 3, and the point is actually around the 3.
How did you know that you chose the cluster as 3?
I don't know. Down the one I write. So I wish I could share my screen so you see what I'm talking about.
Yeah, you don't need to share the screen, but you say it chose. How did you choose? You have to choose.
Okay, I see it now. I get it.
Yeah.
The next line of code, I think I just realized we have to choose the 3. Okay.
So, Angela or somebody else who spoke, I will say that put that thing into the chat and then it will guide you on what the error is. Yes, William.
So I also had an error when I was trying to do it, but I realized that I didn't copy the data. Data underscore skilled underscore copy is equal to data underscore skilled. So I think maybe that's why she's also having the error. So maybe she should run that code before trying to do the clustering.
You mean that people are not running the code step by step?
Yeah, the copy. I think she didn't run the copy side. So if she runs that copy, yes.
Guys, you have to run every code. That's the key point he's saying. And it's true. You can see that I'm running every code. So run every code. Not that the thing is not working. It's because you've not inputted something. So run every code that is there, running. Okay. Now, so if we are, I just wanted to see that this observation I have here might change, okay, by saying that cluster 2 is of very rich countries with high income and GDP. We're going to see whether that is true, okay, because of the clustering that has been differentiated at the back. So we're going to run this command to calculate the mean and the median of the original data grouped by this group that we have. So I'm trying to show my. Let's give it some time. Okay. So I have an error here myself. And sometimes when you get it like this, scroll to the bottom and then see. It says AGJ function failed. Okay. So that is the aggregate. What is that aggregate? But what it simply means is that the aggregate function to do the calculation is what has failed. So we're going to replace this one here with the one I put on the top. In other words, there are string variables in the original data set and it's not helping us. Okay. So we're going to just recreate a new data set called numeric columns. And then we're going to work on that numeric columns. So I'm just going to delete this and be replaced by that. Let's see. There you go. So you can just look at mine and then you can do the same thing. Or I can put it there, in the page for you. And then you can just copy it. For those of you that can. Otherwise, you should just type it. So basically what we're doing is that ideally, we're not using the numeric column because the original data set had a column or country data or country name, Afghanistan, Australia, and so forth. And that we are creating mean and median from that. And it wasn't finding a sensible. And so what we needed to do was to just remove that column, basically. And then, or we should just tell it that go into this data set called data, and rather choose only the numbers in the columns. So any column with a number, choose that. And then we call it numeric columns. And now we will apply the mean and the median on that numeric columns. I hope you guys. And what is going to happen is that it's now going to give us the mean for each cluster. So for cluster 1 or cluster 0, it's got the mean. Cluster 1 is got the mean. Cluster 2 is got the mean. And then cluster 0 is got a median. Cluster 1 is got a median. And then cluster 2 is got a median. Now, I want you to look at the things that he spoke about regarding GDP. So let's look at the GDP for each of the groups. Using the mean, which group has got the highest GDP? Mean, the highest average GDP. Which group? The highest average GDP. I can see it. Do you see it? Which group, which cluster has got the highest average GDP? Can you guys hear me? You have to talk. You don't have to type. Yes, Grace.
Say group 2.
Group 2. What is the value?
29,900.
Good.
Point.
And which is the last? Which is the last group? Pascal.
Say group. The last group is group 4.
No, there's no group 4 here. We have group 0, 1, 2.
Group 1, sorry.
Group 1 is the last group. Okay.
Yes, please.
First
I was
is
using mean, that's why, sorry.
average GDP, which is 1393. This is using the mean. What about using the median? Does it change? Using the median, does it change? Or the same story? William.
I think it's the same.
Yeah, it is the same. So it appears that cluster 1 and cluster 2, they are the rich guys, the rich countries. In fact, when you check their income, it's the same thing. Their income are higher. For example, if you look at the cluster 2, their mean income, it is 34,000 on average. And then their median is 29,000. And then when you look at cluster 1, they are the poor countries. But when you look at cluster, the cluster 0, when you go up, okay, and you look at the observation, cluster 0, they are the ones that are the highest people. You see, a lot of the countries are inside cluster 0. So they are like the average. So cluster 2, 59 countries appear to be what? The wealthy countries. And the 41 countries appear to be the poor countries. And then the 67, the largest group, appear to be the middle guys, middle income or something countries. So already we are coming towards a point where we are able to be doing grouping. This is a whole team. So intuitively, this makes sense. But it's good to visualize a box plot of different attributes. We're going to do a box plot of different attributes for each group to see if we can spot some patterns, very clear patterns. So we're going to take a box plot of child mortality across the groups. Then we take a box plot of export across the groups. Then we take a box plot of income also across the groups. Then we look at inflation across the groups. Then we look at all the rest across the groups. We are just using the names we use, the k-means labels that we use. And the k-means labels that we use were group 0, group 1, group 2. We are going to use that same names. Then we are going to plot for each of the variables and check. Okay, so we got a first one. But let me just expand that so that you can run the same thing. I mean, if the colors were separate, it would have been nice, isn't it? But you know what I mean? The colors were separate. It would have been nice. But from the first instance, what do you notice about the grouping? What do you say? Just looking at child mortality, what would you say? Do you know that the group 2 are the rich countries? And what do you see about child mortality? What would you say about child mortality of these countries? What do you notice about the child mortality? I'm trying to see the possibility of, let me see if I can actually do this. If I can actually do this with different coloring. Let me just try this and see. No? This one. Yes, what do you notice about the child mortality of this country? Let me try this. Yeah. This one is good. This one is good. So, I mean, you can check this. You see, like I just said, it's always good to use these approaches to get things better. So if you check this command, it's slightly different from the one that we did. Okay. The Seaborn box plot, you indicate that the data set should give you, should be split according to colors. So as you can see here, I mean, if you check the first one, there's the first one. It's the same thing. We've listed the rest of the information, but here we have indicated that it should use the coloring to that. I don't know why it didn't do that, but I've just used this command to do that. And it gives the same thing. At this time, with different colors. So you can try this. Because here we've indicated clearly the palette. And so it will set each group with a different color in that context. You can try this or you can use the original one. It doesn't matter. The key point is that. But the key point is looking at this, you will notice from here that the wealthy people have got very low mortality. And then the poor people have got very high mortality. You can see it by looking at the median. The median is the center of each box. The median is the center of each box. So it tells you that the mortality is very, very high among the poor countries, child mortality. Export. You can see that the wealthy people, the wealthy countries, have got a higher export, looking at the center. Of course, there are some couple of outliers in all of them. And then when you take health, okay, the wealthy people appear to be having higher health. And then import. Wealthy people import very well. People think that wealthy people don't import. They import and they also export more. America imports a lot of things from China and also exports more. And when you look at the income of the wealthy people, it's very high. When you look at the poor people, which is cluster 1, it's very, very low. When you consider the inflation level of the wealthy countries, rich countries is very, very low compared to the others. And then the life expectancy is very high for wealthy people, very bad for poor countries, generally. And then when you look at the fertility rate, very, very low for wealthy people, wealthy countries. They're not giving birth by heart. And the GDP, again, you can see that GDP is very high for wealthy countries. very low for poor countries. So what can we say? These are some of the things that we can conclude the profiling for each group. We are coming towards the end of the profile. So 1, cluster 2 has only 3 observations as observed from the scatter plot and the box plot. Groups 2 consist of outlier countries, and you can see a bit of that with higher import and export as a percentage of GDP. They are the wealthy countries. We've said that already. Also, when you look at cluster 1, they are the poor one. There seems to be very poor values for many of the indicators. They have the highest inflation, lowest GDP, lowest export, lowest import, all signaling towards very poor economic situation. They also have the highest child mortality. And they are not thinking and giving. They have the lowest life expectancy, all signaling towards poor state of health. And then this group 1 shows features of underdeveloped and developing countries. We know that these countries seem to have trade deficit because they have more imports than they have exports. When a country has a trade deficit, it must borrow from other countries to pay for them. So again, it's helping you. We are going to see those countries. We are going to see those countries within the cluster. So even if you didn't know that this guy is in a poor country or is in a rich country, this clustering is giving you the clues. Now, when you look at the 0, they are the largest clusters. They're showing both developing and developed. The countries in this cluster have comparatively better state of affairs, many socioeconomic factors, but with a large range of values. And we saw that up there. They are always in the middle. Ideally, we don't want a cluster to be like this because the fundamental idea behind clustering is to group similar things together. And this cluster seems to have a lot of dissimilarities with it. And it's so true because it's in the middle. Okay, it's in the middle. And it's like part of them are poor, part of them are rich. So it makes it a little bit difficult. But generally, this clustering algorithm gives us some knowledge into the potential groups of similar countries. But one thing is that it's not that great because it is affected by outliers. You can see these outliers, in the data most of the time. So if there are outliers in the work, it makes it a little bit difficult to really say that, oh, this is generalizable. Because it might be that a few wealthy countries are those driving the thing, or a few rich, poor countries are those driving the thing. So what do? We have to try other algorithms, not just this one, not just the k-means. We've got to try other algorithms. But before that, let's validate if these clusters relate well with the GDP of the country. So this is a command. We're going to now put them into groups together and see whether they relate with the GDP. Now we are bringing the GDP into the picture. I hope that will not get errors in this. So you should run it along with me. There you go. It's looking good. It's looking good. Let me just expand it. Ah, good. So look at GDP against child mortality. Keep in your head that group 2. See, now we are putting them together. It will also help you the overlaps. It will help you to see the overlaps here. And group 0 are the middle guys, don't forget. So in terms of child mortality, children dying a lot, you can see that group 2, which is the rich countries, they are at the lower section. So you see most of them are in this lower section. And then those are the higher sections are the poor countries. Children are dying a lot. Children are dying. And they also have a very low GDP. So you can see that the GDP is low and the child mortality is high for the poor countries. The GDP is high and the child mortality is low. Graphically, it clearly shows that the wealthy countries are in that shape. Again, when you check GDP against export, export, you want more. You want more, not like child mortality where you want low. So when you look at export, you will see that the wealthy countries, the purple wealthy countries, their export values are high, as well as their GDP being high. And you can see the poor countries. See, there are some poor countries, a few poor countries that seems to have high exports and a bit of high GDP, but not much high GDP, like these ones. They have high exports. Let's say Nigeria is exporting a lot of oil or something, but then the GDP is not reflecting in the GDP. So there are a couple of them. And then there are also some wealthy countries that are really high. Look at this. That's where the outlying comes. Very high GDP, very high export, something. So again, this clustering with the coloring helps us to see clearly, what is happening. And I'm sure it's going to cut across all of the rest. Take, for example, income. That's where the beautiful thing comes, because income is highly correlated with GDP. So you can see that there are some poor countries, one of few poor countries that are a little bit higher income and higher GDP, but majority of the wealthy countries have a very high GDP and high income. There are even some outliers there. But look at the poor countries, they are way down there. They are way down there. So again, it tells us that the results appears to be, consistent with some of the variables, but not all of the variables. Look at inflation. Inflation is very low for the rich countries. Inflation appears to be high for the poor countries. And GDP is still high for the rich countries and low for the poor countries. So again, when you take these variables, look at life expectancy. Again, life expectancy is very high. And you can see that most of the countries that are wealthy have got a high life expectancy. You can see them grouping themselves to the right of them. So your clustering is okay, but there are some overlaps. And that is why we need to verify. And this one is GDP and GDP, by the way. So you can see that one is perfectly correlated. So let's look at the conclusion we can make. Fertility increases the population of the country, which results in lower GDP and net income. We see that. Child mortality negatively affects GDP. A high child mortality can be due to many reasons, like high population density, poverty, and so forth. But that is K-means. We need to try another algorithm. And that algorithm is K-methods. Any questions so far? Again. Any questions so far? So if all of these graphs and tables are provided for you in an exam, you should be able to look at what you are seeing. You should be able to look at it and be able to now document what you are seeing on each one. There will be a trend. There will be a pattern. There will be a trend. There will be a pattern. Okay. Now, K-methods. For the K-methods to work, I tried this thing and it appears not to be working. But to work, you need to pip install scikit-learn extra. Okay. This one. So you need to create a cell and pip install scikit-learn. So please do that. I tried that. Mine didn't really work. Pip install scikit-learn. And if any of you's own should work, let me know. After you've pip install scikit-learn using this command, then you will now load this library. Because the scikit-learn extra, inside it is the K-methods library. The K-methods. Okay. So you do that. Remember, like I said, mine didn't. Let me see whether it will work. But I've done it before. I'm yet to hear it. And I don't think that. I think that It's because the pip install is taking me a very long time. And yes, Angela.
Yeah, Doc, please, what does the feedback access is denied mean?
Sorry?
Because that's what I'm getting. The feedback I'm getting is access is denied.
After doing which one?
After the, sorry, the pip install.
Okay, it says access denied. That's all. Is that all? That's all.
Yeah,
That's all.
that's all. Yeah, that's all.
Yeah, so you put that into the chat and see. Yeah, Jenny.
I think mine worked. Okay, it's installing.
Even if after it has installed, you might come with something because mine did the same thing. But I just want to tell you what is happening because you have the results. Just tell you what is happening just in case. So once you're able to go through, once you're able to install, you just let me know. But let me just continue. Once you install and then load that library, you use KMedo. Okay, we just literally. Remember that we already know that the number of classes are 3, so we use that. We apply it on the scale data, just as we did for the k-mean. And then we run the method. And then we indicate the results. And look at the results that one gave us. It gave us a completely different results from the one we had. It's indicated that the group 2, the members of the group 2 are 58, and then the poor countries are 34, and then the average are 75. The numbers are different, but then the distribution is the same, isn't it? The numbers are different, but the distribution is the same. Now, the next thing is to calculate the mean. Somebody has written something. Yeah. You get to, I've told you already, for some reason. Okay. One has to probably go back and install the 3.10 instead of the 3.12. If you check your Python that you're using, it's probably the latest. And if you're using the latest, well, that's what I was told. I need to go and take the previous. And that is why I had to just hold on, because I didn't have the time to do that one. But if it works and you run this, you will notice that the mean, check here, the mean, check the income, you will see that the income of group 2, okay, which previous one, it was looking good. Look at the income of group 2 rather. It's rather low. It's rather low. And then you check the income of group 0. It's 38,000. And then you check the income of group 1. It's higher. Again, when you check the GDP, I don't want to run this. I don't want to run this because if I run it, just a second. Just a second. When your libraries have worked perfectly, you should be getting results similar to this. But it looks like cluster 0 is rather of very rich countries, okay? And cluster 2 is of very poor countries. Now, it's possible that it has swapped the grouping, okay? And we faced this thing the last time. You remember I said that when it assigns a number, it assigns a number without knowing that it is poor or is rich. So it may have swapped some of this. Okay? And then the rest are in cluster 1, which happens to be the biggest cluster. So intuitively, this makes sense, but you need to visualize the box plot to see what is really, really happening. I normally like it when it is giving the names attached to it, because when it gives the names attached to it, it makes things even. Now, I'm not going to run this thing, like I said before, because of the fact that the original library was not loaded from circuit. When you do that, you see that again, the group 2, look at what is interesting. The child mortality, the group 2 is higher. Remember that here, for the K method, the group 2 has swapped. The group 2 has swapped with the group 0. So you can see that group 2 is having high child mortality, low export, low health, low imports, low income, group 2, low life expectancy, and then everything as opposite of the previous one. So the conclusion here is that cluster 0 have the highest average level, everything that we said. And then look at cluster 0. Cluster 0 shows traits of developing countries with low mortality and all of that. Countries such as Australia, Austria, Belgium, and all of those. And then the count of observations in each cluster from the K methods are more evenly distributed compared to the clusters in the K. And this is because when you look at the K methods, they are less affected by outliers. Okay? And the K means they are more affected by outliers. And if you look at the 3 outlying countries in terms of import and export, you can see that here, in terms of import, okay, export and import. So look at exports here. Okay. We have these 3 outlying countries, and then imports, we have some other outlying countries here. So if you look at that, you will notice, where is that? You will notice, I can't see myself. Yes, Angela.
Okay, so Doug, I'm getting an error for the one you just ran. I want to ask, is it because I ran the cell 22?
You mean the one I got the error myself, right?
No, not that.
Okay, which one?
I mean, just cell 40. Can you go up a bit? I mean, what you just did.
This one?
Yes.
I didn't run this. I didn't run this. You remember I told you that everything I'm going to do with the K method, because the library is not coming, everything I ran here wouldn't work. So I'm using the original results that we had before, to show you. I know you'll be more interested in the 10 running, but don't worry much about that. Be more interested in the explanation. You ask for the running of the commands, I can check it later.
Okay, thank you.
As long as you understand interpretation, that is key. As long as you understand interpretation, that's key, because the interpretation is what you do more with exams. So, unlike the K means, the developed country is much bigger, but it still retains the overall characteristics of the developed countries, which is shown in higher values for the in the other element. So that is how K means and K methods differ in their clustering approach here. The question is, are these the only ones? And there are other ones that you can use. Okay. One of those that you can use is a Gaussian mixture cluster. And I hope that this time that one is going to be showing us something. Let me see if it will. And hopefully it does. Hopefully it doesn't give us errors. There you go. So that is great. So let's start with this command here, the Gaussian mixture clustering. The Gaussian mixture clustering. What is the Gaussian mixture clustering? You guys know that we spoke about it during the theory part. What is the Gaussian mixture clustering? It comes from the word normal distribution of Frederick Gauss. We said it some time ago. There's a model known as the Gaussian mixture model. It's a probabilistic model. Okay. So the Gaussian mixture clustering is basically based on normal distribution, a mixture of several normal distributions. Each of the several normal distributions represents a cluster. So with this Gaussian, what happens is that instead of saying that this point belongs to group 2, the Gaussian mixture will say that this point belongs to group 2 with 70% probability, and group 3 with 30% probability. That is how to say. So you wouldn't say that you belong to group 1 or you belong to group 2, but the probability that you belong to group 1 is this. The probability that you belong to group 1 is 90%, which means that the probability that he too belongs to group 2 is 10%, which is what is right. Because the entire probability is equal to 100%. That's basically what a Gaussian is doing. He's not just telling you that you belong to something, but at what probability do you belong to? Okay, so run the first command, and then let's count which countries will belong to this. Remember, all of them are using the K clusters of 3. So you can see that the N component there is indicating what? That we are using group 3. That's what it's indicating. Now we are going to distribute the groups, the count, the observations across the clusters, across the groups, using this command. And you can see that in this very example, group 0 has got 62 countries, and group 2 has 55, and group 1 has 50. Again, when you add them, you should get a total of 167 countries. And once again, we can take the data set and then find the means and the median according to each group. Let me run that. It always happens because we've identified, because we are using the original skills separated by the scaled copy. If you look at it, we have the scaled copy here. So once again, whenever you have these kind of errors, look at the bottom. It says that aggregate function failed. So you can take these errors and then try and correct these errors, from your, if somebody said Gemini or Copilot or Rock or anything. So this is a very, very huge error that we have. But once again, we just have to change that numeric column section. Okay. So here, see this section here that I have, I will just change that to this. And just let's run it. There you go. So normally that's the one that is causing the problem. It's because it has the string variables in there. So then you have the results. If you follow this, you should get the same result. And what do you see here? Let's take GDP, for example. So you can see that group 2, the mean is 32,000. And then group 0, group 1, the mean is 2,000. So it appears that group 2 is leading here. Remember, the Gaussian measure appears to be agreeing with the K-means that we found. Of course, we are all dealing with a normal distribution. So it wouldn't be so surprising. But here's the thing, that observations or clusters like cluster 1 is of very rich countries with high GDP. That is not true. So if you look at what we have here, and it's good that you can say that that is not true. Okay? If you look at what we have here, the cluster that seems to be doing well is cluster 2, with 32,000 GDP. Now let's go to income. When you look at income, which cluster is having the highest income? It's cluster 2. Oh, my eyes can't see well, guys. Which cluster is having the highest income? Is it not cluster 2? Is it not cluster 2? Yes, Grace.
Yes, cluster 2.
And which is having the poorest income?
Cluster 1.
Yeah. So again, you should be able to edit based on the results you are getting. You should be able to edit your Jupyter Notebook observation based on the results you are working with. That's it. Okay, but let's try to visualize a box plot of different attributes and see once again. Remember, this is Gaussian approach. Everything is what is done at the top. The next ones are just the repetition of the same thing. So we take this one and run for each one. So again, when it comes to each one, you know, bad mortality, child mortality, you can see clearly that that is true. You can see that the cluster 2 is the truly wealthy country. Okay? It is matching significantly with that of the, look at the last one, GDP for each of the clusters. You can see that cluster 2 is leading, and cluster 1 is truly the poor one. So this particular Gaussian mixture algorithm is very similar to the one created. This one, it says created using the K method, but no, it's created using the K mean. Okay. With one cluster countries, one poor, and all of that, no. But in our case, it is closer to the K means that use the normal distribution or the average principle across. It says cluster 1 seems to be developed countries. But you and I know from this result, that is more of cluster 2. Okay. So you should, I mean, whatever it is saying here is irrelevant. The profiling here is irrelevant. You can easily profile yourself based on the results that you have seen. Unless one of you didn't get my result, then if you get a different result, because it's using iterative means, it's using randomization. So if you get a different result, you should use that result to be able to come out with a conclusion there. But let me share some conclusion here, because everything we've done, even though there are differences in the result, agrees with the conclusion that is here. And it is this: the choice of algorithm will depend on the context and the case in use. But purely based on foundations of what good clustering looks like, one can propose K methods as it has more distinct extreme clusters of developing and underdeveloped countries. In this context. So the choice of algorithm will depend. So let me tell you what I would do. I would normally use multiple algorithms. I will use K-mean, I will use K method, I will use hierarchical clustering, I will use Gaussian mixture, I will even use spectral decomposition, I will use DB scan. And then after I've looked at all of these, I will look for those that are similar. When I say those that are similar, which one of them is all pointing towards the fact that cluster 2 is for the rich people and cluster 1 is for the poor people? Which of these algorithms? So maybe out of the 6 algorithms, 4 of them are pointing towards that. Then it means that that grouping is a 1. That is a palpable group. Or all of them, you can see that only the K method out of the 7, only the K method is saying that group 2 is 4. When all the others are saying that group 2 is 12. You will now take the fact that what all the others are saying is key, because they corroborate each other. And that is how you come up with a conclusion when you are doing your analysis. Any question, please? We went through this tutorial the last time. Just let me. Went through the tutorial for the K-means the last time. And I think we even went through, I don't know whether we did, but I think we went through the hierarchical. Did you go through this hierarchical class? I think we didn't. The practical of this hierarchical class. Okay, so you go through this hierarchical classroom, okay, with the information that I've documented here. In fact, I've decided to do it with self-explanatory information. And I want you to go through it with the results, with the information. I put it all here, I've classified all of them there. For both the hierarchical clustering and then the DB scan, the density-based scan. Look at that and then compare that with a spectral clustering, which is this. It's not too difficult at all. It's very, very easy. The DB scan and the spectral clustering are very, very easy. Okay. Look at that on your own, run the results on your own, okay, and then make sense of the results from the answers that I have provided. I want to repeat that. Make sense of the results from the answers that are provided, particularly the summary of the answers. It's just for you to understand how each one of these work and find out the number of clustering that was used for this. It's 2 clusters, but find out if the results are actually showing these 2 clusters. Run them step by step. Okay. Sometimes you just have to bury yourself and run these things step by step. And then you'll be able to and if you find any challenge in doing this, please put it on the page for me, and then I'll write it. But this one, I've already looked at it. Yes, Emmanuel.
Doc, hello, Doc.
Yes.
I just want to find out. So for exams, are we going to produce all these codes?
No, never. You will never produce a single code.
Okay, thank you.
I want you to ask me another question because I've answered it directly.
No, thank you. Thank you.
You will not produce a single code. What's the next one? But when I give you an assignment, yes, Valentina.
Okay, Doc. So if we are not going to be producing codes, what format is it going to take?
Okay, so you're going to be getting an assignment, some of which I think I've given you 1 or 2 assignments. And you're going to have an assignment, and that assignment will give you a project with a data set. And this project or this data set, you will now solve it. That assignment, you will produce your own code to run and address the questions involved. But in exams, you are going to solve things related to, you remember the K-means calculation that we did? In a simple example, manual calculation. That is something you're going to do. For these ones you are seeing, you're going to be giving the result. So for example, okay, you're going to be giving the results. Yes. You're going to be giving a results like a simple data set like this. And then the simple data set will be run. You are giving this information of the elbow plots. Okay. Then you are giving this result here. Of course, a preamble will be given to you. Then this picture is provided for you. And then that picture is also provided for you. Then this spectral picture is also provided for you. Then you are told that on the basis of these pictures, which one is properly classified. Looking at the pictures, where are the similarities, where are the differences as you look at it, together with the sample data that has been provided. In other words, you're going to be doing more of the interpretation of the graphs of the results for the practical part of the exams than you are going to actually write code. And when I say for the practical part of the exam, there is a practical part of the exam and there's a theoretical part of the exam. The theoretical part of the exam is, for example, distinguishing clearly between K-means and K-methods and being able to calculate K-means if you have been given that the number of clusters are maybe 2. In a simple example, how you go and get that value, the centroid, how you calculate the one. That is a theoretical part. That one you are calculating, and then you're also explaining the difference between K-means and K-methods. Okay. Or you're differentiating between supervised and unsupervised learning and giving examples of both of them. That is the theoretical part. The practical part is where you are giving the results and you are interpreting them. But where you actually use your own coding is an assignment that you do. Does that answer your question? The one who asked the question, does that answer your question?
Yes, Doc.
Yes, Doc. Yes, Doc.